times with pinpoint accuracy, these weapons flew into their targets. Come with us as we examine the secrets behind them, the guided bomb. The ability to deliver a weapon against a target with 100% accuracy has been a quest as old as warfare itself. The first serious efforts to develop guided weapons for aircraft took place in World War II. Until then, the most precise strike aircraft were dive bombers and other light attack bombers which struck from low altitudes. But their bomb load was small, their range was short, and they were vulnerable to enemy fire. The long-range heavy bombers of the day attacked from high altitude. This was done to lessen the threat posed by the flak from enemy anti-aircraft gunners. But high altitude meant low accuracy. In 1941, the British Royal Air Force discovered that only one bomber in 10 was able to put its bombs within 5 miles of...
Throughout the history of air warfare, there's always been a trade-off between the accuracy of bombing and the losses that the bombers had to suffer to achieve that accuracy. And so you had to have very brave crews who were prepared to go right into the target to drop the bombs accurately if you were going to do it. Now, the Germans had another problem. They were not a naval power, but they were fighting a naval power, that's to say Great Britain and, of course, later the USA. So what they really wanted to do, they wanted a system that could attack ships, moving ships in open water. And if you take a battleship going at maximum speed, he can cover about 400 yards in the time a bomb takes to come from high level. Why drop the bomb from high level? Because if you don't, it won't have enough velocity to penetrate the deck armor of the battleship. So, for those reasons, the Germans developed two types of anti-shipping weapon, the Fritz X and the Henschel 293, two specific types of anti-shipping weapon.
The Germans were the first to develop successful guided bombs. Their story has been largely forgotten. Guided bombs were hidden under a veil of secrecy. Even after their existence was declassified, they were overshadowed by the more dramatic B-1 and B-2 vengeance weapons. Both guided bombs, the Henschel 293 and the Fritz X, were developed by the same team of German engineers, but for slightly different missions.
The Fritz X was really just a bomb with a radio guidance system, just an ordinary armor-piercing bomb. And this thing, it was unpowered, it was released from about 20,000 feet, and during its descent, it built up to a velocity pretty close to the speed of sound. And there was a case of one of them hit the British battleship, HMS Warspite. It penetrated through 6 decks and blew out a hole in the bottom. The ship was out of action for a year. So this is a very powerful armor-piercing weapon. The Henschel 293 was a quite different weapon. This was for use against unarmoured ships, and it was for use against merchant ships. And this was like a little glider, 10-foot wingspan, and this was released from a much lower altitude. It had a little rocket booster on the back to boost the speed up to about 370 miles an hour, and then it coasted down as a glider until it impacted. The guidance was the system, what we would now call command to line of sight.
Command to line of sight guidance used a radio control system essentially similar to today's radio-controlled model airplanes. The operator used a joystick controller which activated the control surfaces of the guided bomb by means of a radio signal.
There was a flare in the back of the missile, and the operator inside the aircraft had a little joystick controller, and he would steer the missile to fly down the line of sight. And what he did in effect, he superimposed the flare apparently on the target and held it there until the weapon impacted. That was how these things worked.
The missile control joystick was operated by the bombardier sitting in the nose of the aircraft. When the joystick was turned, radio signals were transmitted to the guided bomb. The radio transmissions were translated into control commands to steer the missile. When first used in combat in the Mediterranean in 1943, their results were startling.
Well, they came in with a bang, literally, because the first mission, one of the very first missions that the Fritz X was employed on, that was when the Italian battle fleet was surrendering and it was sailing out to Malta, and these German Dornier bombers caught the fleet and they sank the Italian battleship, the Roma. They got 3 hits on her, started an ammunition fire, and she blew up. Another big Italian modern battleship, the Italia, was seriously damaged. So this suddenly got everybody's attention. This was rather like the later sinking of the Israeli destroyer, the Eilat. Suddenly everybody focused on, good heavens, here's a new and important weapon and we've got to learn how to deal with it.
After the initial successes of the German guided bombs, the Allies attempted to develop new technologies to render them ineffective. The US Navy tried to use electronic means to jam the guidance signal between the bomber and the missile. But the downfall of these new weapons came from other directions.
It was a first-generation system, and you will have problems with the reliability of any first-generation systems. Crews had to be trained up ab initio to use a thing like this. But the biggest problem of all that they had, after some initial successes, the British and the American navies wouldn't put their warships where they were likely to come within range of these units. If they did, they had very good fighter cover. Now, with any sort of air-launched weapon, it's no more effective than the ability of the bomber to get into an attacking position and get it to the target. And this was the problem the Germans found. If these aircraft came under fighter attack, because it was a command to line of sight system, if the bomber had to peel away to avoid a fighter attack, it had to abandon the missile which missed the target.
Like Germany, the United States was fascinated by the potential of guided bombs. The first American guided bomb to be used in combat was the Air Force's Azon. This was a radio command
were.
One of the most revolutionary changes in electro-optically guided...
The important thing about an infrared system is it is able to see through the dark. It can't see through cloud, but it can see in the dark, and so having that system, it confers the ability to operate at night. Now, that may not sound much, but in fact, in recent years, over the past couple of decades, the US forces have moved much more to the night attack mode, when if you've got good night systems, you can operate, and if your enemy hasn't got good night systems, he can't operate. And here again, we saw that in the Gulf War, when the most important operations were carried out at night, and they were achieved with minimal losses. Infrared made that possible.
We may soon see the first true smart weapons, able to distinguish specific types of targets without any human guidance.
As time goes on, electronics gets cheaper, the bombs get smarter. You begin to try to make bombs which can recognize images themselves. That's a current idea. If they can do that, they can be sent in the general direction. The airplane doesn't have to be anywhere near the target. He leaves, the bomb says, yes, that's what I wanted, and that's been everyone.